Hi guys. So you've probably been wondering where I am the last few days. I'm not sure if anybody's kind of told you what's been going on. So I was in the hospital for a few days, but I was able to come home. I'm doing okay now, and baby's doing good now, and I'm just supposed to be taking it easy for a little bit. So I will get back to school as soon as possible. So I appreciate you guys just doing your best for me while I am out. Obviously, we have not graded homework in a few days since I have not been near my laptop or anything. I've been just trying to do everything from my phone and having the teachers at school help me. So we're going to go through those. These are all going to be completion grades, so go ahead and have a pen out. Just fix things as you go. So go ahead and get out your 9-5. That was assigned last Friday. If you need to pause the video while you get these out, that's fine. So number 1, when you look at it, remember for slope-intercept form was y equals mx plus b, because m is our slope and b is our y-intercept. Remember, our slope is our rise over run, and our y-intercept is where it's crossing the y-axis. And remember, we talked about that m is like our move on our graph, and b is like our begin on our graph, okay? So in each equation here, my number in front of my variable, my slope, there's no real number there, it's a 1. My y-intercept was 8. On this one, my slope was 1/3. My y-intercept, there was no plus or minus at the end. That means my y-intercept was 0. If you remember, in this form, like y equals mx, that means it's a proportional relationship. It's a direct variation because it goes through the origin. It goes through 0. Okay. The next one you had to solve for y in order. Hopefully you can see this fine. You had to solve for y to set it up into y equals mx plus b form. So I just added x on both sides. Since x and 5 are not like terms, it's y equals x plus 5. So it's a 1 slope, 5 as our intercept. On this one you had to do the same thing, solve for y. So I added 9x to both sides. 9x and -5 are not like terms, so I can't combine them. So 9 was my slope, -5 was my y-intercept. When you rewrite these, you want to make sure you're always trying to put the x first and your constant last, so that we're always in mx plus b form. If you rearrange these, then it would be in b plus mx form, and that might get confusing for which one's which number, okay? Number 5, remember, this is our begin. That's our y-intercept. So on my y-axis, I start at -2. My slope really here is 1. That means up 1, right 1, up 1, right 1, up 1, right 1. When you are doing this, I would make as many points as you can, or at least multiple. Some of you, when we did our quiz last week, you were only putting like 2, and you were making really big dots, and then you weren't actually going through the lines, okay? If I followed that up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, all the way across, I should be hitting that point every single time with my line. Number 6, 1 is my y-intercept, 1/4 is my slope, so up 1, right 4, up 1, right 4. And the next one, -6 is my y-intercept, so I'm down at -6 on the y-axis. -2 is my slope. So instead of going up, we're going to go down and to the right. That's -2 and +1. We kind of run out of room, so we're going to go the other direction. If I go up, that's +2, but to the left is -1. So remember, -2 over 1 or 2 over -1 are really the same thing. So it's either down to right 1 or up to left 1, and those would be the same. Okay? Number 8. On number 8, it gave you your equation y equals 50x plus 40. You had to graph them first of all. If you did not add the labels on, you will want to make sure you have that. My x was talking about my hours, my y was talking about my cost. When you looked at it, 50 was your slope, and in this case the slope meant, because it says describe what they represent, so the slope meant 50 was the price charged per hour. They told us that right here in the problem. For our y-intercept, that was 40, and that was the initial charge. So the mechanic charges $40 for parts. So before they even fix anything, they have to put $40 into it for parts. So that's where we began at 40, and then it was up 50 over 1, up 50 over 1, up 50 over 1, up 50 over 1. Okay, and it's kind of hard to figure out the 50, so that's why you might want to go up or figure out some points to where I realized this point was going to be right on, and then skip the next point, and the next one would be right on. So even if you didn't have all of those, that's okay. The other thing you could do is just come up with points by plugging in an x value, just like we did on our function tables for our quiz. Plug in an x, find what your y is, there's your ordered pairs. On the next page. Okay, they gave us a situation, they gave us the equation, and we had the graph on this one. So we needed to state our slope and y-intercept and what they represent. My slope is my value in front of my x. It was -3/2, and that represented the amount of teaspoon of nuts per muffin. And then the 15 was my y-intercept, and that's the teaspoons of nuts that she was starting with when she was going to be baking. We can see that here, that's what she started with before she made any muffins, and then you can see it's going down, it's kind of down 1, 2, 3 over 1, 2, down 1, 2, 3 over 1, 2, that -3/2. So it says name the X-intercept. Make sure you weren't paying attention to the y-intercept here. That's normally the one we're talking about, but this time it was the x. So that's a 10. And describe what it means. Well, if this point is 10, 0, that means 10 muffins when there's 0 teaspoons of nuts. So that's how many muffins she can make before the nuts are used up. Okay. Number 10. This one you're going to want to solve for y on this first. So this had a couple steps to it. I had to move my x over. Don't forget to bring down that negative with that 2. It was a minus sign, but now with the x out, it's a negative. So I had -2y equals, I had my negative x that I brought over, and my +8. So from there I had to divide both sides by -2. Remember, when you do that, you have to divide both parts by -2. So -1x divided by -2 gave me a +1/2 x, and +8 divided by -2 gave me a -4. So I begin at -4. My slope is up 1, right 2, up 1, right 2, up 1, right 2. On number 11, I don't have a slope. Since I have a 0 slope, that should be your indication that the line is going to be horizontal here. Remember, this way is a 0 slope, this way is undefined. Okay? So my intercept then was at 6, and I know it's just going to go straight across. Another way to think of it as, it doesn't matter what my x value is, my y is always 6. So 1, 6, maybe 5, 6, -4, 6. Doesn't matter what the x value is, the y always has to be this 6. Let's see. Okay. Number 12. On number 12 it says, what is the slope of the line shown? The slope, it goes from one point to the next, up 6/3, that's a slope of 2. Identify the x-intercept. Where it crosses the x-axis, that was -2. If you put the point -2, 0, that's great. Where it crosses the y-axis, that's my y-intercept. You can put 4, or if you put the point 0, 4, that's great too. And what is the equation of the line? Well, my y-intercept is at 4, and from there I can see I go up 2, right 1, or down 2, left 1, down 2, left 1. Either way, it's going to be a 2 as my slope, so y equals 2x plus 4. 13, describe a line that has a y-intercept but no x-intercept. That's just like this one. This one has a y-intercept, but it's never going to cross the x-axis, so no x-intercept. So that's a horizontal line with a slope of 0. 14, suppose a graph of a line has a negative slope. Negative means it's going to be going down. Going up would have been a positive slope. Okay, but it has a positive y-intercept. So that means when it crosses, it has to cross above the origin. So I just made a quick sketch here. If you look at it, it goes through quadrant 2, it'll go through quadrant 1, and it'll go through quadrant 4. Number 15, find the error. When you look at this, you have to rearrange it for y. So I moved x over. That's subtract x on both sides. That gave me -2y equals -x plus 3. I have to divide by -2 on both sides. Remember, that means both parts here. So -1x divided by -2 is 1/2 x. 3 divided by -2 is -3 over 2. So my slope is 1/2, not 1. And my y-intercept is -3 over 2, not 3. So they took the slope more at this point and did not divide out the negatives there, or the -2. 16, on 16, says the line has a slope of 4/5 and a y-intercept of 10. If you solved those out for y, you would have found letter C had those. I again moved the 4x over, so I had to subtract 4x on both sides. That gave me -5y equals -4x minus 50. Then I divide everything by that -5. That gave me y equals 4/5 x plus 10. Number 17, my begin was -1, and you can see that here. My begin was at -1 on the y, and then my slope was 3, so up 3 over 1, up 3 over 1. The last one, number 18, in this story problem, it was asking for where h is the number of hours, what does the slope represent? So 5 here, and it tells us right here $5 for each hour, so it was the cost per hour. Okay. Remember, when you think about it, our slope is always a rate, because we're talking about a rate of change. So slope always has 2 labels to it, cost per hour, where our y-intercept, our begin, that's just talking about our y, so that's only 1 label to it, $30. This is a rate, $5 per hour. Okay. So once again, this is completion grade, so as long as you checked everything, fixed anything, you had completed all of the problems, you get a 100 for the day on that one. So 18 out of 18, make sure your name's at the top. You can put that in the tray, and when we collect all of them at the end, if you can please make sure they're separated out. So collect this one first, then collect the next one, then collect the next one, just so they're separated out for me to look at when I can return. Go ahead and grab your 9-6 worksheet. So for 9-6, it was solving by graphing. When you graphed, you wanted it to always be in our y equals mx plus b form, so you knew where to begin, how to move. Your solutions were wherever your lines crossed. This is where it was super important that your lines were accurate, that you were using a straight edge so that you knew that your lines were as straight as possible and you were getting the best connection. I don't think I'm ever going to give you, it's not that it won't happen, but as 7th graders, I don't think I'm ever going to give you one where it doesn't cross exactly. So if you're getting something that's crossing like in between, that shouldn't be happening. Somewhere your line's slightly off. So the first one, y equals 1x. That means I have an intercept of 0, and my slope is 1, up 1 over 1, up 1 over 1, up 1 over 1. My begin is 4, my slope is negative 1, down 1, right 1, down 1, right 1, down 1, right 1. We cross at 2, 2. That was your answer, 2, 2. On the next one, and if you notice how I'm circling it matches up with the line in case you're wondering here. So the red one here, I have an intercept of 0, so I begin at 0, my slope is 3/4, up 3, right 4, up 3, right 4. This one I have to solve for y, so I subtracted my 3x over to the other side, divided both sides by 4, and I found it was the exact same equation. So that's going to give me the exact same line. If they're the exact same line, that's infinitely many solutions, meaning anywhere across the line is always a solution for both. Number 3. On number 3, you wanted to either, you had a couple options. Solve for y, so I had to move my x to the other side. Same thing here, move my x to the other side. This one was tricky because then you had to divide by -1 on both parts. The other thing is, if you really struggle with this, you can always plug in an x value and come up with what your y would need to be. So if I have 0, 0 minus what gives me -3? Well, 3. If I have 1, 1 minus what gives me -3? 4. So if you're struggling with rearranging, you can always graph that way as well. Okay? So when I rearranged them, I had a intercept of -3, a slope of -1, so I went down 1, right 1, down 1, right 1, down 1, right 1. This one, when I rearranged it, at a slope of, an intercept of +3, and a +1 slope, up 1, right 1, up 1, right 1, up 1, right 1. That gave me an intercept at -3, 0, so that is the solution on this one. Number 4 was kind of tricky. I was hoping to be there when we did this one so we could go over starting it together with writing the equations. But the two equations, the sum of the two numbers is 5. So any number plus the other number is going to be 5. And then it says the difference of the numbers is 3. So I took my same number minus that second number equals 3. Now, the tricky part on this is, without me talking it through with you, you might have understood what to do here, but you might have accidentally switched it and did y minus x, which is why I put an extra line in here in case you had y minus x. That would have been your line that you had. Otherwise, when you go to graph these, we know multiple ways to graph. You can rearrange it to y equals mx plus b form. Find your begin, know how to move, and graph. Remember, if you don't want to rearrange it, you can come up with ordered pairs. 0 minus what gives me 3. Okay? Or we know how to do x and y intercepts. Remember, for our x-intercept, we plug 0 in for y. For our y-intercept, we plug 0 in for x. And you could find both of those and graph it just with our intercepts. So you have a lot of choices when graphing of how you want to graph and making it the easiest for you. So we did both of our lines, and the ordered pair should be at 4, 1. Once again, if you accidentally switch these around because I wasn't there to talk it through with you, you might have had your solution at 1, 4. Okay, and I understand that might have happened in that case. 5. Intersecting lines are related to one solution. Where they cross, that's one solution. If it's no solutions, that means the lines are going to be parallel. They don't cross, they don't ever touch. Lines with the same slope and different y-intercepts are related to no solutions, as lines with the same slope and the same y-intercept are infinitely many. So again, if they are same slope, different y-intercepts, that means they're parallel, so they're never going to touch, they're no solution. If they have the same slope, same y-intercept, that means they're the exact same line, and so it's going to be infinitely many solutions. back side of this. Number 6, y equals 0. That one, I don't have a slope. I have my intercept is at 0, and so it's just going across everywhere. Y is equal to 0. Doesn't matter what my x value is. Okay. So the next one, my y-intercept is at 4. I have up 1, right 1, up 1, right 1, up 1, right 1. So my solution was at -4, 0. That's where they crossed. The next one, number 7, x is equal to 2. So I went to my x and put 2. And again, since it says nothing about y, it doesn't matter what my y value is, x is always 2. So notice I have my x can be 2 when y is 5. My x can be 2 when y is -2. Okay, so it's going up and down if it's x equals. I know that kind of seems weird because our x-axis goes this way, but if it's x equals something, that means I'm on that one value for x, and this value is always 2 for x, going straight up and down. On this one, my intercept was at -4, slope of -1 went down 1, right 1, down 1, right 1. They crossed at 2, -6, so that's my solution. On number 8, I have y equals -1, so -1, I'm looking at here, and again, doesn't matter what my x value is, y is always -1, so it's going to go a horizontal line across. The other one, there's multiple ways to think this one through again. You can rearrange it, so you have your y equals mx plus b. You can plug in values for x to come up with your y. You can do your x-intercept, y-intercept, and plug in 0 for x when you find your y-intercept, plug in 0 for y when you find your x-intercept. I might have accidentally just said that backwards. But as you're going through this then, I rearranged it and I ended up with y equals x minus 6. So my begin is at -6. I went up 1, right 1, up 1, right 1, up 1, right 1, until I find it crossed at 5, -1. Number 9, on this one, Amy took 3 times as many pictures as Jennifer, so 3 times Jennifer is what Amy took, and Jennifer has 16 fewer pictures than Amy. This one might have thrown you for a loop, but you might have been thinking it was the minus ones. But since we're talking about it in terms of Amy, Amy has more, Jennifer had less. So Jennifer plus 16 gave me Amy's there. Once you looked at this, if you had number 9 correct, number 10 was kind of easier because you could have just plugged in numbers to see. 3 times 8 gave me 24, and 8 plus 16 gave me 24. The last one, where is the solution? If you look at it, it's at -1, 1. They did the lines for you, you just had to figure out where that solution was. Once again, that one's a completion grade, so it's out of 11. Make sure your name's at the top. As long as you did every problem, you were fixing problems as you went, go ahead and give yourself an 11 out of 11 on that, and we'll collect that one at the end as well. So at this point, you should have one more, and that's your 9-7. This one's a long one. I'm sorry, I was planning on cutting it down for you, but again, I did not have any of my stuff at the hospital with me, and so I kind of just left it up to the teachers at school to give you the worksheets and cut anything down if they thought they needed to. Plus, I thought you were going to have plenty of time to watch the video and start this, but then Mrs. Martinez realized she accidentally did not post the video for you guys yesterday, so again, I apologize on that. So hopefully you kind of understood this. This one's probably the most difficult lesson out of the ones we've talked through so far. And just letting you know, we will be doing a review and then your test. If I am not back before your test, please do not panic. No, I'm never going to let you fail if you're struggling with some of this. If I see scores aren't normal for you from the test, we'll talk about things of maybe doing some corrections or some retakes or things like that. So don't panic that I'm not here and you're not getting some of this and you're going to struggle and your grade's going to drop. I wouldn't let any of that happen for you, okay? So have 9-7 out. On this one, there's a lot of work to all of them, so I might not talk through the whole solving because you can kind of look through it. If you need Mrs. Wise to pause the video so you can see the work a little bit longer, that's totally fine. But I am going to talk through how to substitute in. So on each one, what you're trying to do is substitute something in so that you don't have two different variables. You can't solve when there's two different variables. So in this case, I took my first equation, y equals negative 2x, and this means y is the same as negative 2x. So instead of writing y, I can write negative 2x, and they mean the same thing because it told me negative 2x is equal to y. So I'm just replacing it. That's what substitution means. Replace it with something that's equal. So you have your equation then. Now that there's one variable, I can solve. So we want to get the variable to one side, all of the constants to the other side, and then finish solving. Once I have one of my variables, I plug it back in. Typically, I go with whatever was solved for that equation already. So like I highlighted all of this one because it was solved for y, so I just plugged it back in. Negative 2 times negative 5 gave me a positive 10. So my ordered pair was x is negative 5, y is 10. On this one, I took x plus 2 and plugged it in for y. So that gave me x plus 2 here, and then minus 2 equals 12x. On this one, a little bit different than the last one, you had to combine like terms first, they canceled out, and from there, when you move your variable over, that's a 0. So it ends up just x is equal to 0, plug it back in, and you get y is 2. On the next one, I plugged in 6x minus 8 for x here, or I'm sorry, for y here, and I don't know, I didn't write these out. I'm not sure why it's flip-flopped here. I would have written it out as 6x minus 8 here equals x minus 3. This is just flip-flopped from it. I had my y on this side here, and then this part over here. So we have variables on both sides and constants on both sides. Remember, to solve, the first thing you have to do is move all of the variables to one side. So we did that. Then we moved all of the constants to the other side, did that, solved and got 1. If you plug it back in, 6 times 1 is 6, minus 8 is negative 2. Okay, or you could plug it into this one if you really wanted. 1 minus 3 is also negative 2. So it's not like you have to know which one to plug it into. Either one, it's going to come out to be the right answer, as long as you solve for your first variable correctly. Number 4, these are the easier ones when it tells us already what one of the numbers is. We like these. So y is equal to 4. When I plug that in, that's 4 equals x minus 2. Very quickly I find x is 6. Make sure you put them in the correct order. X is first, y is second. Another one, I already solved for y for us, so I plugged it in, get my constants to one side, make sure to get rid of that negative 1 out front by dividing by negative 1, and you get 18. So 18, negative 5. Number 6, I plugged in 10x plus 24 for y. So again, not sure why the last teacher rearranged these when you did it, but I would have written here 10x plus 24 equals negative 6. It's the same thing, just rearranged. So subtract 24 on both sides to get my constants on one side, variables on the other, finish solving, and I got x is negative 3, and remember, it told us y is negative 6. So I didn't have to plug it back in. If you forgot that this was already here, when you plug it back in, 10 times negative 3 is negative 30, plus 24 is negative 6. So either way, you're going to figure it out. Number 7. On number 7, this one was kind of a tricky one. So we have y is equal to negative x. So I plugged in negative x here, got my variables all to one side, divided and got negative 2. When you plug it back in, be very, very, very careful. It's negative x. So that's really negative 2. And a negative, excuse me, a negative times a negative is a positive, so that's negative 2, 2. So y equals 0 on this one, so I plugged in 0 here. I divide by negative 2 on both sides, and it's still 0. That one's just 0, 0. This is where it starts to get a little bit more complicated on some of these. So on number 9, what you would do is, there's a couple different ways to think it through, but I ended up using all of this, plugged in for y, so I did my x equals 4 times, and instead of y, I wrote out 4x plus 45 here. Now, since they're right next to each other, that means they had to be in parentheses. Okay, so then I had to distribute. 4 times 4x is 16x, 4 times 45 is 180. Get my x's to both sides, divide by negative 15 on both sides, and get negative 12. The work up here is me plugging it back in afterwards. 4 times negative 12, I'm sorry, I plugged it in on the wrong part. Here, x, negative 12. So I divided by 4 on both sides and ended up with negative 3. Or I could have done 4 times negative 12 is negative 48, plus 45 is negative 3. Either way works, okay? This is one of the more complex ones. I can't remember if I put something like that on your test or not, but if there is, it's only going to be one, okay? You're going to see some more like this, maybe one like this, but I would not put multiple of them like that are complex. Same with the next few, okay? So the next one, what I did on this one is I had my 2x minus 8 plugged in for y here. So I had 2x minus 8 plus x equals 4. I had like terms on that side, so I combined them, got my constants to one side, divided, got 4, plugged it back in. I know if x is 4, 4 plus 0 has to be 4. Or I'm sorry, yep, so 0. Number 11, kind of a tricky one. On this one, so we have two x's here, so we ended up solving for that. I added x over, so I got my variables on the same side, and that was 2x equals my negative 2. Divide by 2, and I got x is equal to 1. I would not give you one like this on the test because that's just a more complex one. So x equals negative 1, and then I plugged it back in. So 9 minus negative 1 gave me a positive 10, so negative 110. Number 12 on this one, you're plugging in 4x minus 3 for my y. So it was 4x minus 3 equals 3x minus 1. I know you could do one like this. Okay, it's just plugging it in for y. We know how to get variables to one side, constants to the other to solve, and then plugging it back in. So I would expect to see maybe one like this on your test. Okay. On the next side, I'm just going to kind of let you look over this one because it's just like number 12. You have this on one side, this on the other. Because they're both set equal to y, you can just set them equal to each other. This one is another one like number 9, where you plugged it in, and since you're plugging it in, you're plugging in y minus 2, a quantity, times 3. You have to have it in parentheses, and you had to distribute through, combine your like terms, get the variables to one side, and all of that. This one is the one I want you to look at. Again, this is another big, complex one, okay? Once again, if I was there when we assigned this, I would not have given you all of these tricky ones. I would have taken a few out, left a few in for you, but I'm sorry I wasn't, and so you got to try all of the tricky ones. So good news is this homework was way more difficult than what you're going to see on the test, okay? So on this one, I plugged in I solved this first one for y. Neither of these were solved for a variable, so I had to solve for y first, so I knew what I would be plugging in for it. When I did, I got 2x minus 11, so I plugged that in for y here. So 3 times the quantity 2x minus 11 minus 6x equals negative 33. I distributed. When I did that, 6x minus 6x are on the same side. Those cancel each other out. Remember, if they come out to be equal to each other, that's infinitely many solutions. Anytime they don't equal each other, that's when it's no solution, okay, or that null set. I know I will give you a story problem on the test, so you have to write out your equations first, then solve them, so it's a little bit more complex. Number 16, admission fee at a carnival is $5 for children, so that's where my 5C came in. $8 for adults, that's where my 8A came in, and it says that it's going to be a total of $7,300. So $5 per child plus $8 for adult is this total amount of money. The total people, so all of the children plus all of the adults, were 1,250 total people. Okay. From there, neither of them were solved for a variable, so I had to solve for a variable I just randomly picked. Doesn't matter which one you solve for. I solved for C. That meant I had to move my A over. Since we're not graphing, it does not matter if my variable is first and my constant is last. If you like to keep it that way, fantastic. You would have had negative A plus 1,250. But since we're not graphing, it really doesn't matter on the order. So then what I did is I rewrote this, but instead of C, I put the quantity 1,250 minus A. So I had to distribute here, combine my like terms, get my constant to the other side, divide by 3 on both sides there, and I got A is equal to 350. Now when I plug that back in, 1,250 minus 350 gave me 900. So my solution here, it's not really an ordered pair at this point, it's what are they talking about. That's why we pick variables that we know what they're standing for, not just X and Y. The adults, there was 350. The children, there was 900. Number 17 says, Darcy placed 2 orders for flowers and bushes. On the first order, there was 24 flowers and 6 bushes. That was a total of $144. Second order, 18 flowers, 3 bushes, total of $90. Once again, nothing was solved for the variable, so you had to solve for a variable first. That's what I'm doing right here. So I moved my 18F over, so it was 90 minus 18F. I had to divide each part by 3, so that gave me B is equal to 30 minus 6F. Once again, pick a variable to solve for, doesn't matter which one you're choosing. Okay? Once I knew what B was equal to, take the other equation. Don't use the one you just solved for. So if you solve for this one, use the other one now. I kind of forgot to say that here. We solved for this one, so I had to use the other one then. So I plugged them in for B, so I had 24F plus 6 times my quantity here, that 30 minus 6F equals 144. Distribute, combine like terms on the same side, move the constant to the other side, solve and got 3. Since it's 3, when I plug that back in for F, I just used the one that I already had solved for here. So 30 minus 6 times 3, well that was really 30 minus 18, so that's 12. So that means the flowers, F, were 3 each, and B, the bushes, were 12 each. Last one, very similar to the one before, 8 muffins plus 2 quarts of milk is $18. 3 muffins plus 1 quart of milk, 1 is my coefficient here, is $7.50. I just solve for a variable. Since this one has a coefficient of 1, that makes it the easiest to solve for. So I just moved my 3m to the other side and had Q equals 750 minus 3m. So plug it into the other equation. Had to use my parentheses, don't forget about that. So 8m plus 2 times this quantity here equals 18. Distribute, combine my like terms, get my constant to the other side, solve, and I find m is 1.5. That means my muffins cost $1.50 each. When I plug that back into this one, 750 minus 3 times 1.5 is 4.5, so 750 minus 4.5 is 3. Each quart of milk is $3 each. Okay? Now, this one, once again, 18 points because it is just a completion grade. So if you attempted every single one, if you were working on fixing them, I know I went through them very, very quickly. So if you were working on fixing them as I went, you get a 100, 18 out of 18, put your name at the top. Again, when you collect them, please make sure they're grouped so that I have each assignment together, not just your stack of assignments together. If you have any questions on things that I went over, please make sure you are writing them down. You can either email them to me, save them for when I get back, but like I said, I don't know exactly when that will be. But if you email them to me, I can try to send you an email response with the answers. Hopefully some of this is making sense. If you're feeling a little overwhelmed, the good news for you is that everything with systems of equations, so this part and this part, both of these assignments, all 8th grade content. Okay, so none of this is going to show up on your state test this year. So again, we're working towards understanding this for our test. Don't panic if I'm not back before your test. Right now, the plan is for the test on Friday this week, okay? But do the best you can. I appreciate you guys working hard for me while I'm not there. And again, email me if you have a question on something, okay?